Hello and welcome back to the course. So in the last session we learned about basic data types like integers, floats and strings, and also we learned about basic operations like addition, multiplication and so on. And now in this session we are introducing variables. So what is a variable? Let's assume we have an integer object 5. We can print it out. And instead of having the 5 as the number itself, we can assign a variable. Let's call it a. So a equals 5. And Python now makes internally a reference that whenever we call a, it's calculating 5 or it's returning 5. So if we now just print a, we are getting 5. So a stands for 5. And as we learned in the last session, we can also print out a by calling the print function. So that's actually here the same. And we can also change the reference. So if we say, okay, a was 5, but now a is 7, we can just change it. So a is 7, and let's check if a is now 7, and a is 7 now. So we can simply change our reference. So before our reference was to 5, to the integer object 5, and now a reference is to 7, so we can change the reference. Alright, so let's introduce another variable. Let's call it b equals 2, and we can also print out b is 2. And in the last session we have learned that if we want to print out both a and b in one cell, so by default, Jupyter Notebook only prints out the last statement or the last line, it's b here. So and if we want to print out both, we have to call the print function, print a and b. So now we can print out both 7 and 2. Alright, so basically we can do with variables the same as with integers or floats. We can do the basic operations like addition. So we can take a plus b is 9, a minus b is 5, b minus a is minus 5. We can also multiply, so a times b, and we can, of course, we can also divide a divided by b. And now, for example, we can assign the result of a divided by b. So it's 3.5. We can assign a new variable c to it. So c equals a divided by b. Let's print out c. So c is 3.5. And we can also check the data type of c. So I would expect that it's a float. Yes, exactly. And of course, we cannot only assign a variable to an integer or an float, we can also assign a variable to a string object. So for example, we have dog, and we can assign the variable d equals dog. And we can of course print out d. So internally Python makes a reference from the variable d to our string object dog. So d is dog. And we can also check the data type of d, and it's a string. So dog is a string, of course, and d is referencing to dog, and d is also a string then. And for a variable name, we can actually make any name we want to have. So we can say my favorite dog is Lassie, for example, and this works. Now if I want to print out my variable, my favorite dog, I can start typing my, and by pressing the tab key, so Python automatically completes my variable. So now I have Lassie, so that's called the tab completion. So Python knows that a variable called my favorite dog is stored internally, and whenever I start typing my Then I can press tab and yeah, Python automatically completes my variable. So that's quite helpful actually when the variable is quite long, like here in that case. And what I would also like to highlight is that I need the underslash here. So if it's just a space, my favorite dog, so that cannot serve as a variable. So here it gives me an error message. So space is not defined as part of a variable actually. So it only works in this way. And also a string itself, like let's say dog. A string like dog cannot be in variable. So dog equals Spike gives me as well an error message. And also an integer or a float cannot be in variable. So let's say 5 equals Spike, let's say. It also doesn't work. But an integer can be part of a variable. So let's say dog5 is Spike. So that works. And there's one last thing I want to highlight here. So let's assume I assign to the variable e equals 10. So e is 10. And then I assign f equals e. F equals e. So in this case, f is 10 because e is 10 and f equals e, so f also must be 10. And now if I change e, so before e was a reference to the object 10, if I change e to let's say 15, and I again check the reference of f, so f is still 10, even if before I referenced f equals e. So what happened internally? So internally here, an object 10 was created and it was referenced to the variable e. And here when we say f equals e, then internally a reference to the same object 10 was created to f. So we have one object, integer 10, and we have two references from 10 to e and to f. And if we change here the reference to 15, internally a new object 15 is created, and the reference for e was changed from 10 to 15. But there was no impact on f, so the reference from f is still to the integer object 10, not to 15. So that's quite important to understand here how Python works internally. Alright, so that's it. So thank you very much, and yeah, I hope you enjoyed it, and see you in the next lesson.